Quiet, Chris. What are you laughing at? What's up? I know, I saw that. Yeah. That'd be so bad. All right, everybody, we're going to get started with our keynote. Again, I know it's a little bit packed and everything, but I appreciate coming here. Hey, everybody, be quiet. Thank you. Appreciate it. That worked, surprisingly. That's right. I want to thank everybody for coming out here to our opening keynote with Matthew Graber. Matt's over at Spectre Ops, and I've followed Matt for years and years and years and years. One of the top people that I'm one of the most humble and also one of the top researchers in our field today. I follow all of Matt's stuff. I think between Matt and Subverting and a few other folks, they're literally driving a large percentage of the research that we see out there today. Matt is just a phenomenal and awesome person. I know that his keynote today is going to be epic and amazing, and it's going to kill any other keynote that's ever been done before in the past of keynotes. Sorry for that. But anyways, give a round of applause for Matt Graber. Thanks for coming out here, Matt. Appreciate having a DerbyCon.
Thanks a lot, Dave. That's awesome. So I actually gave my first InfoSec conference with Chris Campbell years ago here at DerbyCon. So to be invited back here to keynote obviously is quite humbling. So thank you, Dave, for the opportunity. So yeah, apparently I have a pretty high bar to meet. So hopefully I'll blow some minds. All right. So today I'm going to be talking about trust in Windows and ways in which we might be able to subvert it in some pretty stealthy ways. All right. So what I want to do in this talk is I want to give like your typical HackerCon talk, compress it a little bit. So what's the way that a typical hacker talk goes? Well, first you introduce a concept. Obviously, the audience members are not going to be super familiar with the research that you've been working on, so you got to bring everyone up to speed. So of course I'll do that. Next, you'll challenge some assumptions, right? So you'll get them thinking that, everything's working just great, and then, you start asking some leading questions, getting the audience members thinking a little bit, and then you blow some minds and hack some things, right? So usually this will follow up with popping a calc. Oh God. Oh, damn it. Okay. Disaster averted. So, and then, sometimes following up the, cool hack that you just showed off, there might be one slide at the very end just giving some lip service to how you might go about defending these sorts of things, network segmentation, application whitelisting, like, oh yeah, that's easy, right? So I'll be doing all these things. I'll follow that with, I want to try to inspire some people out here. So especially if you're new into InfoSec. Now I know we have a lot of veterans here. I'm staying in front of many of my heroes and mentors as I speak, so that's extremely humbling. I don't consider myself to be like elite researcher or anything. Like I'm just like everyone else. Like there's a particular approach that I take to security research that I think is ultimately very approachable. So I'll share with you my thought process behind making the discovery that I did, and then give some pro tips to try to convince you that security research ultimately is very approachable and not that hard of a thing to engage in. A little bit about myself. You see I'm the proud owner of this the CEH here. Talk to me after the talk, and I've got a story about this. This picture was taken, I think it was after the second time that EC Council was hacked, so funny story about that. As Dave mentioned, I work for Spectre Ops. I'm pretty new there. Security researcher. I work with amazingly bright people. Our guys are giving a bunch of talks today and throughout the conference. So I'm humbled to be working with them and just surrounding myself with all these awesome people. Like this is my absolute favorite conference because I really feel like I'm with family. Like you go down the escalator, I'm pretty introverted myself, so like I'm kind of forced to like force my way through LobbyCon, and you can literally just go up to anyone, strike up a conversation. Everyone's super approachable, and I love it. So everyone probably already has, but if you haven't, check your ego at the door and talk to anyone. Like this place is awesome. I love it. People who know me well know that for better or for worse, I'm also a huge PowerShell fanboy. So of course there's going to be a significant PowerShell portion in this talk as well. All right, so part one. The what? Here's the technical meat of the talk. So here's the scenario. We want to, as an investigator or a malware analyst, we suspect that Notepad might be doing something weird. So maybe at runtime, it's calling out to some C2, just doing weird stuff. And we'd like to investigate, first of all, is notepad.exe itself backdoored? So we'd like to quickly make that determination. So as a malware analyst or a reverser, first thing you might do is start with some basic dynamic analysis. So what does everyone like to do? Run the binary through strings, right? Is anything going to stand out to you? In this case, just running it through strings, nothing really stood out to me as super odd. So this is sort of like my level 1 triage. Nothing stood out to me, but still I knew that Notepad was doing some weird stuff. So I want to continue my investigation a little bit. So I loaded up into a PE parsing utility. This is one of my favorite ones, Cerbo Profiler. One of the first things that I'll do is if I suspect that it's a backdoored binary, like a backdoored Microsoft binary, I'll look at the debug strings. So this is usually like kind of a cool indicator. Like oftentimes attackers won't cover their tracks, and you'll be able to see some like interesting file paths to like where they built their binary. So this doesn't really stand out to me as suspicious as well, because in the red box that you see here, it only has notepad.pdb, so that's like the original file name, and it doesn't have the full path, so that usually indicates to me that this probably originated from Microsoft. But I still don't know at this point if it's actually been backdoored. Maybe the attacker was super stealthy and embedded, like maybe they use like the Backdoor Factory by Josh Pitts to really cover their tracks and embed themselves in Notepad. So then, I might start getting frustrated, be like, hey, what's the deal? Like, I don't really see anything suspicious. I might throw the binary into IDA Pro, look at the disassembly or decompile it. For the uninitiated, if you haven't been doing this for a while, and you haven't like looked at potentially backdoor binaries, you might start to get pretty overwhelmed. And honestly, like, you might start trying to find evil where there's not. For example, like one of the most common API calls in Windows binaries is debugger present. Right, so it's a common anti-debugging technique, but it's also used all the time in the C runtime initialization code before the main function is called. So to the uninitiated, this might be a really frustrating exercise because nothing still is standing out to you. So just stop what you're doing, like slow down, all right? We don't have time for that. Like, we're in the midst of a high-profile investigation, and we need to quickly triage if Notepad and potentially thousands of other binaries have been backdoored. So again, no one has time for that. So what I recommend you do, I've certainly done this for the longest time, is if you want to rule out that the suspect binary came from Microsoft, then run a signature validation utility on it. So this uses digital signatures to validate who it came from and the integrity of the binary. So me being a PowerShell fanboy, of course I'm going to use the PowerShell equivalent, the get authenticode signature commandlet, run it on the suspect notepad, and then I'll also compare it against a known benign file, in this case kernel 32. And I see that both show up as valid, meaning that both the hashes match against the hash that is signed in the digital signature, and also the hash of the certificate itself, also referred to as the thumbprint. So SHA-1 hash of the certificate value itself matches that of the known benign kernel 32. So at this point, I'm pretty confident that Notepad is completely benign and originates from Microsoft. There's no other reason to lead me astray. Now, as a good investigator, you may not rely upon a single tool. You might use multiple tools because there's user mode and kernel mode rootkits that can lie to you all the time. So back up your claims by using some additional tools. So there's a tried and true sig check to do the same thing from sysinternals. There's also signtool as well, which is available in the Windows SDK. And these are all basically returning the same thing, indicating that Notepad probably originated. At least there's some pretty good cryptographic guarantees stating that this Notepad likely originated from Microsoft. And most incident responders would probably agree. So in this super unscientific poll that I conducted, half of the people who responded said that they would likely use a signature validation utility as like that first level triage to quickly rule out whether or not this system file is benign or if it was backdoored. Totally reasonable in my opinion. So quick background into code signing. Just at a very high level, digital signatures for code is meant to achieve two things. It's supposed to inform you of who the entity was, so who the signer was. In this case, I'm interested in, I want to know if Notepad actually originated from Microsoft. And then it's also supposed to guarantee the integrity of the binary. So after it was signed, was it either corrupted or backdoored in some ways such that the hashes would not match? In which case, when you run the signature verification utilities, it's going to indicate that there's that hash mismatch that occurred, right? So when we talk about the entity, we're referring to the certificate itself. So it's an X509 ASN1 encoded binary blob, which contains all the entity information. So, to indicate that in this case it came from Microsoft again. And then the other portion of the digital signature is the signature itself, which is a signed hash. So it's not a file hash, it's an authenticode hash, which is just the actual executable code itself. A hash of that is taken. That is then signed using the private key. So the private key is the owner of the most sensitive part of the digital certificate, which no one is supposed to have access to. And then the public key is embedded in the certificate itself. So that code, when it's running, or you run the signature validation utility, it can do that check using cryptographic guarantees. Okay? Now, you should not think of digital certificates as proving that something is benign. Those who are probably familiar with what's going around in the news, the crap cleaner compromise. So the attackers compromised their signing infrastructure, signed a malicious update. So really all a digital signature guarantees, as far as the entity is concerned, is that whoever controls the private key is that entity. So in the case of crap cleaner, it was the attackers who were the verified entity in that case. Okay, so with all these digital signatures and entities, who should I ultimately trust? Well, you could have Microsoft tell you, and this is the way that things just kind of work out of the box. Like when you use Chrome or Edge to browse to, say, Twitter, you might have noticed in the top left, there's like a green box that says, Twitter, verified, certificate, whatever. So this is like an extended validation certificate that's backed all the way up to, there's a chain of trust. And so at the top of that chain of trust is all of these certificates present in the certificate store. And so if everything verifies up to that chain of trust in the certificate store, then yes, you're good to go. Because otherwise, if these things weren't like trusted by default, then you would have a really crappy browsing experience. Signed code might not work right, like if you're in an application whitelisting scenario. So that's sort of the reason why those are there. All right. You could also trust no one and explicitly trust either hashes or digital certificates that you explicitly trust. So this is just a little dump of a code integrity policy for DeviceGuard, a newer, like really strong, great application whitelisting utility for in Windows 10 Enterprise. So here I'm explicitly saying these are the hashes of these certificates that I trust. And this is a reasonable thing to do if you want to really lock down system, to trust the signers themselves, because if you don't trust Microsoft signers, then you're not going to have a system that's going to boot or even update for that matter. So this is a totally reasonable thing to do. So what is the lesson here? Digital signatures, as I said, are a great way to make that really quick, benign classification. So it allows you to quickly rule out what you know to be good, allowing you to focus on what you suspect to be bad. Now, as I stated, the signing certificate is only good as the security around its private key, as the crap cleaner compromise has shown us. And code signing verification requires strong crypto and, almost more importantly, a correct and resilient implementation of that crypto, those crypto algorithms on the operating system in which the validation occurs. All right, let's do a demo. So, on the system that I'm presenting from, I have a super lockdown DeviceGuard policy. I'm only permitting Windows signed code to execute. Nothing else can run, okay? So what I would like to do is execute the following code. So just a simple hello world. This will execute just fine. But because device guard is locking the system down, it's not going to let me do certain things like add type, which allows you to compile C# code and load it on the fly. So that would sort of break the guarantees of application whitelisting if I could just compile and load my own unsigned code on the fly. It's a totally reasonable thing to do. And then I'll try to execute it. And I tried to be smart about this. And what I did was you can sign PowerShell code. I took a legitimate PowerShell digital signature and just copied and pasted it into this code thinking, hey, something might work. Maybe they won't validate a hash mismatch. So let's give this a shot. Let me show you the other portion of the attack. So the first thing that we're going to do is validate that we are in constrained language mode. So this is the super lockdown mode of PowerShell that when device guard or app locker is enabled and in enforcement mode is really going to lock things down. I've got two scripts. So I've got the bypass test.psm1, which I just showed you, the hello world one. And then I've got my, quote, backdoored notepad, all right? So, everyone see this okay? Okay, so I'm running get authenticode signature on the scripts that you saw and my backdoored binary, both of which I've applied a legitimate digital signature to. So it supplies this thumbprint, which I know to have originated from Microsoft, but in the status, it shows hash mismatch. Like this is how code signing is supposed to work, and it's working properly, so that's great. So I'll try to execute my code. It should be locked down. Okay, hello world prints, but then I get this error saying that I'm unable to call add type because of the restricted language mode that I'm in. So everything is working just as I suspect it will work. Now, what I'm going to do is I'm going to flip 2 registry values. That's it. 2 registry values. Oh, you know what? Oh, okay, I'm good. In this registry key, HKLM software, Microsoft cryptography, OID, encoding type 0, cryptsip DLL, verify indirect data, and the subkeys I'm going to modify are these seemingly random GUID values. And what I'm going to write to them, to the values, in the DLL and func name keys is the following. Anti-DLL with the function dbgui continue. Okay? Cool? Now, I'm going to start a new PowerShell process. Refresh things a little bit. Let's run get authenticode signature on these files again. We're valid. So, for all intents and purposes, upon modifying those 2 registry values, I am Microsoft. I validate 100% as Microsoft. I can be whoever I want to be by flipping those 2 registry values. It's pretty cool. Now let's execute my payload again. I should not be able to execute this add type command. It's supposed to be locked down, right? Pardon my switching back and forth here. Let's try that again. We're good to go. No errors. We executed that. So both the PowerShell, the signed PowerShell code, and my backdoored Notepad executable, again, all intents and purposes, I am Microsoft at this point. I could be Google if I wanted to be as well. I can be anyone I want to be on this compromised system. But I didn't drop any malicious code to achieve this attack, and by modifying registry values, I can do that remotely. So it's not going to be that hard to get admin privs, maybe like flip these values using WMI and do all this remotely. So I was pretty pleased with this outcome. Turned out that, yeah, this was a device guard bypass. This likely bypasses other application whitelisting solutions. And also, it just kind of breaks the concept of trust. right? Like digital signatures are supposed to guarantee that you came from an entity, assuming that the private key wasn't compromised and that the integrity of that signed binary was intact, right? All right, so now let me start to explain like my thought process behind that, because like to the uninitiated, like that would seem like magic, right? Like how the hell did you come up with flipping those registry values to NTDLL DBG UI continue? It turns out it was really easy, but what I find to be frustrating often is, we see all these mind-blowing research presented all the time, and I'm just left like with my jaw dropped, wondering like, how the hell did you figure this out? Because you only have 45 minutes to present a new concept, challenge those assumptions, and then break some things. Rarely do you have enough time to cover your entire thought process. But let me try to do that in my allotted time. All right, so here's kind of where I started. Again, me being a PowerShell fanboy, and once I started using Device Guard more, I started getting in the habit of signing my code. Like, it's just a good practice to get into. And so, like, how do you sign binaries? In PowerShell, you set authenticode signature to achieve that. So I'm pulling up the help, looking at the description. I see the set authenticode commandlet adds an authenticode signature to any file that supports a subject interface package. What the hell is that? No clue. Google to the rescue, maybe? So I actually didn't find a whole lot about this, but I did find this really brief MSDN article from 2008 from some guy named Eduardo. Thank you, Eduardo. And he describes very briefly what is a SIP. So they tell the crypto API how to hash the file and where to put the signature. Like, this makes sense. Like, there has to be code somewhere that signs code and validates the signatures, pulls out the certificates. Like, it just makes sense to do that, right? So apparently the crypto API is what achieves this via a SIP. So where can I find these SIPs? So basically, it's any file that generally ends with sip.dll. So for example, MSI sip.dll is the subject, is the SIP for the Microsoft installer for MSI. So like, yeah, you can sign and validate the signature on installer files. You can do it for exes, DLLs, .sys, .ps1, all kinds of file types, you can sign them. But the way in which they're stored is going to be slightly different. Now, how can I use them? In order to use a SIP, you have to register it first with regsvr32. So I'm a malware reverser by trade in a previous job, so I've seen the malicious use of regsvr32 in the wild a lot, especially when Casey came up with an app whitelisting bypass for that. We're definitely starting to see this in the wild a lot more. So I know that regsvr32 is used to register something, typically in the registry. Okay, so let's start investigating this. I just did a scan in System32 for all files that ended with sip.dll, and a few results came up. The one that stood out to me the most is the PowerShell one, so PowerShell sip.dll. What does this thing do? I have no clue, but let's start digging in. So I wrote a PE parser for PowerShell. I use it pretty frequently, so I wanted to look at the export functions that are implemented in this DLL. One of them, or two of them, is DLL unregister and register server. So if you were to Google this, you would see that those functions are indicative of something that is designed to be registered with regsvr32. Okay? I don't know how they're implemented, haven't gotten that far yet, but we're on the right path, I think. There's also all these additional really interesting exported functions here. So PS verify hash. That's interesting. I've talked about hashes a little bit in hash validation. So there could be something interesting going on here. I'm going to have to dig in. PS put signature, presumably this is what inserts a digital certificate into a signed PowerShell file. Again, these are all just assumptions I'm making that I need to validate. So again, we know that PowerShell code can be signed, and this is an example of what PowerShell signed code would look like. So you have the code followed by this base64 encoded blob. And so, again, presumably, it's PS put signature in PowerShell sip.dll that would stuff that signature into the PowerShell code. Something has to do it, so it might be this. So let's start reversing this. This isn't terribly complex. I did some markup in IDA hit F5 to decompile it. It's an easy thing to do, right? And I see in the DLL register server implementation, it calls basically just like one function, cryptsip add provider. Well, I don't know what that does, but I see it's passing pointers to a bunch of strings. And these are the export functions that I saw in PowerShell sip.dll previously. Okay, so naturally, again, I go Google or Bing what cryptsip add provider is. I look at the structure that's passed into it. It's documented somewhat. I'm still a little confused. I don't have enough background at this point to fully understand how the system is working under the hood, but I keep digging. And one of the things that came up in clicking through the links in the MSDN documentation was I was really interested in that PS verify hash function. And so some of the documentation that came up was this verify func name thing. So it's a pointer to a null terminated string that contains the name of the function that verifies the hash. So the signature for this function pointer is described in cryptsip verify indirect data. Let me flip ahead real quick. So cryptsip verify indirect data has the following function signature, right? So it takes two parameters. What those parameters are and what they consist of, I don't really know at this point. And then it returns a Boolean. And in the documentation, in the return value section, it says the return value is true if the function succeeds, otherwise false. Well, what are the conditions for success or the conditions for failure? Again, I still don't know. I need to dig into this. So I was also curious as to like where potentially in the registry all this stuff was registered after regsvr32 was called. So I pull up regedit, just do a string search on the function I was interested in this case PS verify hash, and sure enough, I got one single hit in the registry key that I showed you in the bypass before. So that cryptzip DLL verify indirect data, followed by that seemingly random GUID value, and here you see the DLL and func name of the legitimate functionality to do this hash verification. So PowerShell sip.dll, PS verify hash. So I'm thinking to myself, you know, could I possibly implement my own hash validation function and then just replace the DLL and function name with that of the one that I implemented myself? Why not? What's the harm in trying? So I digged a little bit further. Oftentimes, if you find that MSDN docs are lacking, go download the Windows SDK, and there's like hundreds or thousands of these header files, which often provide much more explicit detail beyond what MSDN docs will give you. So in this case, I didn't really get a whole lot of extra information, but there's a lot of additional context, and context is everything in security research and reverse engineering. So, you know, I'm just, I'm connecting the dots as I go. I'm taking notes every point along the way. So again, what if? What if I just implemented this function by myself? So again, according to the documentation, it took those two parameter types. So again, I don't know what they do, but I'll just take them in, whatever, and I'll simply return true. What's the harm? So I compile it, replace the path to my DLL and my implementing export function, again, the one that just returns true. And a side note, remember there was the hash mismatch? So I needed to take a legitimate digital signature, apply it to my unsigned code. So in this case, like I just went to isc.psm1, legitimately signed file, took that base64 encoded blob, applied it to my unsigned code. So now I'm like signed by Microsoft, but the hash mismatch error would probably occur, right? But now I've just implemented my own hash validation function. It just returns true. And sure enough, it worked. So here, get authenticate signature at the top. I'm validating the signature on the legitimate benign file, isc.psm1. This is the one that I stole the signature from. And now when I run get authenticate signature on my unsigned code, it validates just perfectly fine. And you see it even has an identical thumbprint value to the one that I stole from the signature, from the legitimate signed version. So I'm a happy guy, doing my happy dance. And I wanted to validate that, you know, it wasn't just Microsoft, you know, or that it wasn't just PowerShell. Maybe there was a flaw, an implementation flaw in get authentic code signature? Maybe not. I don't know. But so I pulled it up in the Explorer UI. Many of you have probably seen the digital signatures tab, and I validate 100% okay. So it turns out I validate 100% okay in any tool that performs user mode signature validation, including sysinternals. So I thought, can we do better? Can I not drop a binary to disk and not use any malicious code whatsoever to achieve the same effect? So would this attack work in an app whitelisting scenario? So it's kind of a chicken and the egg problem, right? I'm dropping an unsigned hash validation DLL that's not signed, so is app whitelisting going to catch it first before it does the validation? So I don't really know. So I want to try to do this without having to drop any code. So is there any signed code that has an export function that might replicate the functionality of cryptzip verify indirect data? So basically, any signed code that accepts 2 parameters and returns a non-zero number. So a non-zero number in C is the equivalent of true. Sure enough, I did some digging. After about 10 minutes of looking at implemented export functions in IDA, I came along DBG UI continue. So it takes 2 parameters. What they take, I don't know. I don't even know what this function does to date. But looking at it in a debugger, I saw that it consistently returned a non-null value, in other words, true. Okay. It also had the benefit of not having any, at least to me, noticeable side effects on the operating system or the arguments that were passed in. Because like if you're overwriting pointers and the arguments that were passed in, then that can lead to memory corruption and you're just going to crash random crap, right? So this was a good candidate. And so again, here's the same attack, only I'm just flipping the registry values and not dropping any malicious code. Cool stuff. And it also happened to be a device guard bypass for certain subject interface packages, the PowerShell one being one of them. And the reason for that is because there's some validation that occurs in the kernel, and as you extend all these subject interface packages, they're probably not going to support all those new ones in the kernel, so that's the reason for that. So I have a lot more information. I have a 60-page white paper that goes into explicit detail about the user mode trust architecture. There's a crap ton of additional attacks, including a ton of ways to persist in the context of security products, various sysinternals bypasses, as well as I cover in explicit details all the ways to detect this. It's actually not that hard to detect these things. I also have a proof of concept malicious SIP. So if you want to play around with this yourself, what I implemented was once you register this SIP, any file extension that has .foo or .bar, if it's signed or not, it doesn't matter. It's always going to return the digital signature that's embedded in it, and by default, it's just going to be a Microsoft one. So any foo or bar file, if you run like get authentic code signature on it, it'll be like, yeah, I'm Microsoft, I'm good. And also for defensive purposes, I'm releasing 2 new functions in SimSweep so that you can scan for this kind of compromise at scale. More tools. So if you want to learn how to apply legitimate digital signatures to your own code, there's various ways to do that depending upon if it's PowerShell or a P executable. So I have a blog post that describes how to do that. Go read that if you want to learn more. There's automated tools to do this as well. Josh Pitts wrote one in Python. My boy Chris Ross just wrote one in C# called SigPirate. So go check those out if you want to start playing with this stuff. So what's my anticipated reaction to this research? Well, come on, you had to be admin, so this is like a post-compromise technique. Okay, well, great. I mean, I guess we're done here. Nothing further to investigate, right? Well, no, again, all I'm doing is flipping registry values. So if you're not searching for these and sweeping for these, then you might be missing something. And then, the uninitiated incident responder might think that might think that your malicious code is completely benign and originates from Microsoft or Google or whatever, right? So you might already not trust digital certificates, in which case, great. You're probably using multiple tools to validate trust by whatever means. At scale, this can be challenging. If you're trying to quickly triage and rule out as many benign samples as possible, it can be hard. Now, there's also pitfalls as a security vendor. What if, as a security vendor, you treat everything as if it was unsigned? And then you have like the DNS client service calling out to some shady domains, right? Just because you're a shady person, you browse to some shady websites, and then all of a sudden your next-gen security product flags the DNS client DLL service as malicious. Well, you're kind of screwed at that point, and the entire ecosystem is screwed. Right? So we need to be very careful about how we validate trust using digital signatures. So some of you might be asking, well, what the hell can I trust anymore? Well, we can clearly state that you had to be admin to conduct this attack, so you're potentially performing an investigation on a system that is already suspected to be compromised. So just take that into consideration. If you take the same binary that appears to be signed on the compromised system and compare it on a known not compromised system, then you're going to get that hash mismatch error, and you're going to see that something is up. Also, you should always establish multiple data points to establish trust. So not only digital signatures, but there's a lot of like online reputation services that you can subscribe to. So use sort of a holistic approach in determining trust. And again, these attacks are relatively easy to detect. All right, so some more background, like how did I arrive to this discovery in the first place? So have any of you ever said or asked the following questions after you saw some mind-blowing research? I sense probably most of the people in this room have asked or said at least one of these things. I know I have. So it can be very frustrating to see what it otherwise looks like complete magic, and here you are sitting there just mind-blown, having no clue how the researcher figured this stuff out. So, I've been there. So here's my approach to security research. So embark upon a journey with no destination. Just go along for the ride, right? Like, we're all really experienced in our respective subject matter. Like, I'm not a web app guy, so like, I don't know that whole field. But I'm sure if I was, then I might be able to apply some of that experience to other disparate fields that would allow me to apply a unique perspective to the problem that I'm working on, right? So, now, when you're in that talk, completely mind blown, thinking, oh God, like, I want to be this person, like, I'm just hero worshiping right now, this is amazing. What a lot of people fall victim to is creating overly audacious or unrealistic goals, right? So, in 5 years, I want to be like elite reverse engineer or exploit developer. Like, I'm going to tell you, like, you're going to get really, you're going to fall victim to anxiety and depression if that's the case, because 5 years in our industry is a lifetime. Right? So look back at yourself 5 years ago, and would you have any idea you're doing what you're doing now? And the answer is probably not. I'd say that's true for at least 90% of you, right? Become a subject matter expert in your respective technology, even if it's not 100% related to what your regular job duties are. There's a lot of like game console hackers out there. Like, those people are amazing. Like, and that's usually not their regular everyday work, right? If it is, then good for you. That's amazing. But you'll be able to apply your unique mindset to what you do every day on the job. Or if there's like additional research that you want to do, just again, those unique experiences provide unique perspective. One of the ways that I learn new things is I write parsers all the time. Like, I wanted to learn how the P file format worked, so I wrote a P file format parser. I failed many, many times along the way, especially when running like super obfuscated, like packed binaries against it. And then I just learned more about the file format. So like, I know it like the back of my hand now, and I know all the subtle nuances in ways in which attackers can modify P files to try to evade detection. And again, technology changes at such a rapid pace, like it's hard enough to keep up. So again, if you're setting those lofty goals, it's probably unrealistic. Like, just go along for the ride, have fun, like dive deep, and who knows, like something amazing may come up. So what specifically led me to this discovery? Honestly, it was just happenstance. So let me take you back in time through some of my history to tell you how I arrived to this discovery. So saw a talk a long time ago by this guy. I don't even know who that is, to be honest, but he gave a really awesome PowerShell talk. So he really inspired me to start digging into PowerShell. So I started doing that, kind of entered my script kiddie phase, doing kind of like writing silly scripts that I thought were like so amazing at the time. And then like I discovered like I could write a shellcode runner in PowerShell. And then it was like my first or second DerbyCon. I go up to Dave and I was like, hey man, you totally inspired me with PowerShell. I love your DEF CON talk, is amazing. Hey, I wrote this shellcode runner in PowerShell. And he was like, oh, dude, that's amazing. That is really, really cool. Like, I didn't know at the time. Like, I was pretty new in the industry. I didn't know if he was just blowing smoke up my ass and being a nice guy or anything. Like, I didn't think about it then, but it was totally validating of the work that I was doing. So, like, that really motivated me to keep continuing in writing offensive PowerShell stuff. So I continued doing that. Ended up creating PowerSploit along with Chris Campbell, and it's had amazing development ever since. Lee Holmes at Microsoft, who used to be on the PowerShell teams doing awesome security stuff in Microsoft, approached me, gave me all these like pro tips on how to write better PowerShell code. So he's been a huge mentor for me along the way. Again, like continue to provide that validation that I'm sort of on the right path and doing some cool stuff. More PowerShell, and then like eventually Microsoft was wise to this. Like people started using PowerShell for attacks in the wild all the time. So like this was kind of becoming a problem. So security in PowerShell, especially in version 5 now, like got really, really freaking good. So at that point I had a decision. Should I either divest in PowerShell or should I continue with my passion and start trying to find bypasses for all these new security implementations? And so I decided to continue, found a bunch of bypasses along the way, but then Microsoft has come along every single time without fail, and pretty much every single bypass out there, if they haven't fixed it already, then they're already working on one. So like big shout out to Microsoft. Like PowerShell, like I'll argue about this like anytime, any day. PowerShell, like for any scripting language, is the most secure, like has the best security optics of any other like runtime language out there. Like, I'll argue about this anytime. And then, come to today, and then, we have Dave who looks like this now, so let's give Dave a big round of applause for that amazing transformation. Awesome. So I met a lot of people along the way. Has anyone had the pleasure of meeting Sub T or Casey Smith? He's up here. So he kind of looks like this guy, right? So if you've met him, yeah, that's definitely Casey. Casey really motivated me. Like I like to think we're kind of on the same wavelength in terms of like the research stuff that we're interested in. So like he really just continued to motivate me and push me to find new ways of abusing trust, because Casey's all about that as well. So then I got to Device Guard. So this Device Guard posed a unique opportunity for me. I wanted to learn a new technology. Like I wanted to be like the Device Guard security guy. Like I want to know this better than anyone. I also wanted to up my tradecraft game. So what better way to find like the living off the land techniques than by doing so with your hands tied behind your back with a really strong application whitelisting solution. So Device Guard was that for me. And so I also want to learn the limits of how effective it was. Like, how does it actually implement signature validation and enforce that accordingly? So along the way, it also just really continued to solidify just the concept of trust for me. And I'm still, to this day, asking myself, like, what is trust and what does it mean to me? And I think you guys should be asking that question to yourself as well after this talk. Some additional skills that I acquired along the way that obviously helped: C, reverse engineering, debugging. Also, root cause analysis is like a really, really valuable skill to have in reversing and security research. And so next, like, okay, I am where I am now. What do I want to do next? I don't really know. Like, I've taken good notes. So let's see. I'm open to whatever may present itself in the future. So, for example, like, what are some other ways I can subvert trust? So another way that you can sign stuff is using catalog signatures versus authentic code. So there's a lot of opportunity there to explore. And by all means, if you're interested in this, go look into catalog signing and go find some cool bypasses. To what extent is validation done in the kernel? I still don't really know to this day. Like, I have a host of bypasses for user mode stuff, but I'm sure there's a lot of potential in the kernel as well. And finally, trust is actually a really important concept to bootloaders. So the lower level you go, digital signing becomes a lot more important. And there's a lot of like hardware and firmware attestations of trust that can occur. So like there's so much more research to do out there. I'm like a total bootloader noob, but I know a lot of really smart people on Twitter who do that stuff. So I can approach them with some educated questions, and they'll be more than happy to help me along the way. And finally, this happens to me all the time. This probably happens to you a lot. Like, there's a shiny thing that distracts you from whatever research you're working on. Embrace the shiny objects, right? Because again, like, whatever distraction you may be going down, so maybe you're like procrastinating on some like work task that you're supposed to be going on. But what I find myself doing is like, when I'm procrastinating on one thing, I become hyper productive on something that I shouldn't be working on at all. But who knows? Like, this could turn out to be like a really valuable thing that I'm looking into. So, I mean, do so sparingly. Like don't overbill your hours or build the wrong bill code. Like, be productive members of society and make your company money. But do embrace the shiny objects, maybe preferably during your off time. Also, learn to appreciate the process as much as the result. So here's a Jackson Pollock painting. Now, I'm not much of an art critic myself, so like I don't really have much of an interpretation of like what the hell this painting means. But like what I'm super fascinated by is what was the process that took place in creating this fine piece of art. Like, I want to get into Jackson Pollock's head, like, because I know that he was really meticulous about every stroke or like hurling of the paint that he did. Like, I want to know what his emotions were. What is he thinking when he developed this, in my opinion, amazing piece of art? And also, another source of inspiration for me, and I love that more hackers are starting to do this, is watch some of the live streams on YouTube out there. I don't know if any of you guys know this guy in the in the screenshot. This is OJ Reeves, one of the lead devs on Interpreter. Amazing security researcher. So like he did this live stream. He was like hacking this device driver. And so like I don't remember how long this was. It was maybe like an hour. And he's like just walking through his whole thought process. And so like rather than like him being up on stage and being like, hey, I did this really cool stuff. Let me show you what I did. Like he's walking through step by step what he's thinking, failures and all. Like failure is extremely important to document in security research because it leads you to the right path usually of where you should be going. So what are the lessons in security research in my opinion? I really think at a minimum you just need these traits: curiosity, persistence, humility, and honestly stop comparing yourself to the achievements of others. Like we all fall victim to hero worship. We get frustrated when we think that, some task is completely unachievable because it's so far out. Just drop the labels, whether you consider me to be like an actual security researcher or not, like I don't really care. Like I just go do fun things and make some interesting discoveries sometimes. And always record your ideas and stash away those crappy like POC code samples that you write. I can't tell you how many times I go back like 3 years later and find this like terrible code like that I'm ashamed of, but that's like completely relevant to what I might be working on like 2-3 years later. So like keep that stuff, try to like version control it, like just stuff it away somewhere because you'll be really surprised how practical it might be later on. And always acknowledge that, again, disparate skill sets lead to creativity. So finally, I just want to thank everyone here, pretty much everyone in this audience. Is super approachable. So I want to thank anyone who like exhibits any of these qualities. Like these are the qualities of like a good researcher, in my opinion, and just good all-around people in general, which all of you are. This is my favorite conference. Like everyone's so approachable. Again, like I just love it here. So thank you everyone for what you do and the enthusiasm that you bring. And thanks a lot for letting me be on stage to present this.